With all the natural disasters in the world today, hurricanes, fires, floods, how do you protect your loved ones? Galexa homes are built safer, stronger, and faster than any other home on the market today. And best of all, they're affordable. Galexa homes are made of cement and steel, no wood. The future of home building is here. All Galexa homes are non-combustible, Class A fire rated, prevent progressive collapse, and are hurricane rated at 250 miles per hour. Galexa homes will look great and keep your loved ones safe. Call Galexa today.
My name is Jillian Franz. I work for Shield Industries, and I am a fire specialist and logistics manager. We manufacture a variety of protective coatings for the retail consumer as well as an industrial end user. Today we are at the Georgia Public Safety Training Center to conduct an experiment using the FireGuard E84. The people here that are helping to conduct the experiment are fire officials, contractors, and building code officials. We have constructed 3 buildings, 2 untreated buildings with latex paint, and then we have 1 treated building with the FireGuard E84. What we're going to do today is light an ignition source in the 2 outer buildings, and the radiant heat from the untreated building will flash over into the other untreated building. Then the treated home with the FireGuard E84 will maintain intact. During the experiment, I was surprised at how quickly the untreated buildings were fully engulfed in flames. It took probably 5 minutes for them to be fully engulfed in flames, while the house treated with the FireGuard E84 withstood the flames for at least 20 to 30 minutes. What we had was a board. One side was treated with 2 coats of FireGuard E84. The other side was treated with a white latex house paint. And we were trying to simulate what you would see inside of the burning building, with the torches exposed directly, simulating the fire that we had inside the home. The FireGuard E84 creates a thermal barrier in order to prevent heat transfer so that the wood doesn't flame up and catch fire. As you can see here, the left side treated with the latex paint will burn through, and the right side with the intumescent paint will begin to puff to the surface to create that thermal barrier. I think this product could significantly affect building code and zoning laws because it will allow firefighters more response time to arrive at the scene and also save lives by allowing more time for people to evacuate. And it is significantly cheaper, less labor, and less material costs for contractors.
Researchers put a 6-story, lightweight, cold-formed steel building through a scaled motion measured during the magnitude 6.7 Northridge earthquake. The shaking of the wall-braced building took place on the world's largest outdoor shake table at the University of California, San Diego. This is part of a larger project aimed at understanding how cold-formed steel frame structures withstand earthquakes and fires in order to develop ways to make buildings safer in earthquakes, fires, and other disasters. The researchers are deploying drones before, during, and after earthquake simulations, as well as during live fire tests, in order to map the structure and capture video of the damage. One of the big picture goals of the drone research is to develop better methods to quickly assess damage in buildings, bridges, and other infrastructure after an earthquake or other disaster. The 6-story building's layout is designed to replicate a multifamily residential structure. It is equipped with water heaters and stoves which could ignite a fire if they move too much during an earthquake. The appliances are both braced and freestanding to evaluate which restraint systems are most effective. This is the tallest cold-formed steel frame structure to ever undergo tests on a shake table. The researchers want to know how the 64-foot structure will perform during the series of simulated earthquakes. This type of structure is lighter than a concrete building of the same height, so it has less mass to generate damaging forces. The building will undergo fire testing after the earthquake simulations. The researchers are working to evaluate the distribution of loads and failure mechanisms within the structural components of the building, and to validate computer models that can be used to predict a structure's performance during different earthquakes.
Gain the competitive edge with the latest low VOC product innovation from the industry leader. Icynene ProSeal LE offers the opportunity to achieve R35 in an initial 5-inch pass. This high-performance innovation makes Icynene ProSeal LE suitable for both residential and commercial projects, allows construction schedules to be shortened, and can be applied in temperatures as low as 23 degrees Fahrenheit. Icynene ProSeal LE helps architects and builders confidently meet today's building code requirements. It allows for an initial pass of 5 inches, achieving R35, and is classified as a Class 2 vapor retarder at 1.5 inches. Icynene ProSeal LE is GreenGuard Gold certified. Plus, the low VOC formulation allows for re-entry by trades after 1 hour, and reoccupancy by building occupants after 2 hours of active ventilation at 40 ACH following installation. This means that construction schedules can be shortened and occupants can return to the building the very same day. Icynene ProSeal LE closed cell spray foam features an R value of R7.1 per inch, is suitable for use in 1 to 5 construction types, can be sprayed in temperatures as low as 23 degrees Fahrenheit, and is GreenGuard Gold certified. Plus, as a closed cell spray foam insulation, Icynene ProSeal LE meets the criteria set by FEMA for resisting bulk water, making it ideal for use in buildings in areas prone to flooding and hurricanes. Learn more about how Icynene ProSeal LE spray foam insulation can be used